Hi everyone, welcome to this session about Catalyst SD-WAN Enhanced Application Aware Routing. My name is Karthik and I'm a technical marketing engineer for the Catalyst SD-WAN product. There is a live poll during this session, so please join us on Slido. If you are joining live, you can use this QR code. Otherwise, you can use the below link and it will pop up on the WebEx to answer the poll question. Your feedback is really appreciated. So without any further ado, let's jump into the agenda here. So I'll talk about why enhanced application aware routing, give you an overview of what enhanced application aware routing does provide, and then I will go into the deep dive discussion about what it is and how it is working. Then I'll talk about the migration scenarios, and I'll talk about like the configuration using templates or configuration groups or CLI. Finally, last but not the least, I will do a live demonstration. And I pray to the demo gods to make sure the live demonstration goes fine. If we have any challenges or run into glitches, I do have a recorded demo and I have the YouTube link posted at the end of the slide in the reference section towards the end of this deck. So with that, let me give you a table, like let's just set the stage here, right? So you have different market segments on the left where you have all the way from healthcare industries towards the bottom at the finance. All these different sectors or verticals depend heavily on applications. These applications are critical to their business. They run business on these applications, and these applications could reside over the wide area network, and they could reside on any destinations like private data centers, private cloud, or through reachable through the business internet or public internet. And what is more critical is SD-WAN has to provide this application experience, and it is one of the table stakes. Catalyst SD-WAN solution provides a lot of different capabilities in order to optimize the applications when they're going through the fabric. One such focus today is about the application aware routing, where our solution actively monitors the tunnels and it measures the path quality, and we can dynamically steer the applications to a different path that is optimized depending on the network conditions. And talking about network conditions, I have a quote here from the below source. If you look at these applications, why they become crucial is that they are impacting the organization's revenue. So it can directly impact their revenue when there is network degradation condition, and it can also cause like lower decline the employee productivity. And if this network degradation condition continues for a period of time, it could also damage the organization's reputation. This kind of reinforces the fact that I was trying to explain in the previous slide why application optimization is really important. Cisco Catalyst SD-WAN solution offers all this for you. So with that, Tanner, can you post the first poll questions?
Yeah, our first poll question is now live using the Slido panel or the Slido link. The first poll question, what is your current comfort level with Cisco Catalyst SD-WAN application aware routing? We'll give you all some time to go ahead and provide your answers with that. And Karthik, we'll head right back to you.
All right, thanks, Tanner. So moving forward, just I want to give a quick recap. This is a reference slide, and what this slide talks about is today our solution does monitoring of the SD-WAN tunnels whenever you bring up the fabric between the SD-WAN edges. So we monitor the path quality like loss, latency, and jitter across these qualitative metrics across these different paths like internet, MPLS, 4G, 5G, irrespective of what transport. And then using application aware routing policy, you can set up an SLA for a given application. And using that, we measure this constantly. And if there is an out of threshold indicated, we will move the traffic for that application using a different path. And this is all done dynamically. So gone are the days where just doing the routing based on the IP packets, destination IP. Those are not going to be existing in today's world. So application aware routing provides this capability, and this is what we call as SLA based routing. The way we do this is by using the bidirectional forwarding detection in our solution. So on a SD-WAN edge, we send these BFD probes every hello interval. A hello interval could be like 1,000 milliseconds. And these packets monitor the path loss, latency, and jitter that's happening on the network. And we accumulate this information over a period of time, which you see in this slide is the pole interval. So until that duration, we can get an average path loss, latency, and jitter. And then we do this accumulation over a period of multiple pole intervals to give us accurate measurements. And this is what we call as app route multiplier. When we get this results from this calculation, we compare that against the configured thresholds for a different application. And whenever we see that the SLA has been breached, we move the traffic for this application to a more optimized path in the network automatically. Now, just a quick recap and key points to remember before I jump into the enhanced application aware routing. BFD continues to be the mechanism in the Catalyst SD-WAN solution for detecting the WAN outages, like the total WAN outage, like when there is a transport link failure, and is also used, as explained in the prior slide, for application-aware routing to detect slowly degraded WAN circuits. And today's session, we focus on the improvements we made to detect the slowly degraded WAN circuits. Introducing enhanced application aware routing. Enhanced application aware routing takes the application experience to a next level. We made these three improvements on the top, on the right side here with the 20.12.1 release and 17.12.1.a release software version on our SD-WAN edge routers. It does improve our measurements that we monitor today, like loss, latency, and jitter. We're doing more improved measurements using inline data, and we use BFD for reporting and fallback. We're also, because we are able to improve these measurements, we can now react faster by moving the traffic to a more optimized path in the order of seconds. And last but not the least, we are also monitoring the stability of the WAN and doing SLA dampening by default. And I'll talk about each of these key points in subsequent slides. So what's new in the 20.12.1 or 17.12.1a? So imagine like you are a network architect and you have a problem today, or you're challenged with, you want to improve your application experience with this new release to a 10x times more than the prior releases. And you want to improve this when there are WAN degradation issues happening on the WAN, right? When there are soft degradation issues. So the network architect proposes this solution, which is the enhanced application aware routing, which now leverages inline data for qualitative metric measurements. And it provides enhanced reliability because now we can have more accuracy and we can react faster in the order of seconds when there are network conditions like packet loss happening on the WAN, or when there is delay, where there is jitter. What this provides also is a smooth application experience, which is going to be helpful. And by monitoring the unstable network conditions, we often hear from customers and large ISPs, the network conditions doesn't get better like in just a minute. So continuous monitoring of these network conditions will allow us to provide this dampening capability, which is SLA dampening, to monitor the stability so that your applications have like a good experience on the network. Some of the caveats that are listed on the bottom right side of the screen here. So if you have your SD-WAN edge device with the loopback as TLOC configured and you're using unbind mode, enhanced application aware routing is, there's a limitation we will not be able to support in that. And also if you have like GRE tunnels between these SD-WAN edge devices, you would want to know that there won't be per queue loss measurements. So what is inline data actually mean? Inline data is nothing but your application data flowing through the SD-WAN edge device. This is actually part of your overlay network header inside SD-WAN tunnels. So we take the actual data that is flowing through the router to our SD-WAN edge device to calculate path loss, latency, and jitter. So how we do these measurements for loss? So today for loss, we do per queue loss measurements on an SD-WAN edge device. So if you classify your applications into different classes of queues, imagine a forwarding class is like a QoS group in traditional iOS XE world. And when you classify this traffic into different queues, we are able to do per queue loss measurement. And for that, we leverage the adaptive cost metrics, the adaptive cost used to use, and we're using the same infrastructure to give this differentiator loss in the SD-WAN network versus loss that's happening on the local box or the local SD-WAN edge device. The loss measured is one directional. So whenever you have an SD-WAN edge device, you have a remote SD-WAN edge device, which is going to be the receiver. The receiver will report the loss again using BFD to send us to help us measure the unidirectional loss. So one key differentiation that I would want to highlight is that we are able to do like per queue loss and latency and jitter measurements here with our solution. So the latency and jitter, we use these measurements at a queue level again, and we use like standards-based algorithms. We use a patented method to insert metadata, and I'll talk about that in the subsequent slides. And again, like we are going to measure the jitter as unidirectional because you know that jitter is directional sensitive. And again, like in loss, the receiver would report the latency and jitter, excuse me, will report the jitter back to the sender using the BFD. Latency is still round trip time measured, so it is round trip time, and loss and jitter are unidirectional. So for latency and jitter measurements, what we do is since we add this metadata, we intelligently use data packet sampling, and we pick up a packet every 100 milliseconds and we add timestamps to it. And we also ensure that the packet doesn't exceed the MTU on the wire, so to avoid fragmentation. And we do this automatically once you enable this feature. This is taken care, and then again we do per queue measurement for latency and jitter. Enhanced application aware routing improves your tunnel degradation detection time and switchover time by doing accurate metric measurements using the actual data packets that is flowing through the SD-WAN edge device. Now, because we are able to have like accurate measurements, we can react faster, we can take action to move the traffic to a better, more optimized path in as low as 10 seconds, between 10 to 60 seconds. And we are able to avoid constant issues on the network instabilities happening on the wide area network using the dampening capability. In order to just give you an insight into how the metrics look like when you have enhanced application aware routing, as I said, we are able to react faster now between 10 to 60 seconds whenever there's a issue we detect on the soft tunnel degradation issues. And we have better accuracy. Why? Because we are using inline data packets that is going through the SD-WAN router, and we are also leveraging BFD when we want to report, and we are also using the same algorithm we have in application aware routing, and we are also using BFD in case like you don't have any data traffic as a fallback. For loss, all packets are accounted and measured. And for latency and jitter, like I said, we do a sampling of one packet every 100 milliseconds. In terms of loss, just to reiterate what I said earlier, we do unidirectional. It is using inline data for plus BFD because for reporting from the receiver to the sender. Likewise, jitter as well is using unidirectional inline data and BFD to report. For latency, we use round trip latency using inline data and also BFD as a fallback mechanism for all these three. Tanner, I would like you to now post the question number 2 to the audience.
Of course, poll question 2 is now live. Does your current Cisco Catalyst SD-WAN network have the application-aware routing enabled? If not, are you planning on enabling this capability after attending this webinar? We'll give you all some time to provide your answers for that one as well.
Thank you, Tanner. Now, let's look at the deep dive on enhanced application-aware routing. Just a quick recap what an application probe class is, and this is there since 20.4 release in our SD-WAN solution. So app probe class provides a queue and DHCP mapping to an SLA. By doing that, we can do more granular per queue measurements at a queue level and at a DHCP level, and at a like a WAN transport, like because of this mapping we provide. As defined here, like you have an app probe class at the bottom left, real-time video. It's mapped to a forwarding class, which is like a QoS group called video. And then it is using for DHCP 34 for color MPLS transport. And again, like this DHCP 40 for business internet, and for public transports like LTE, we use DHCP 0. So once you define this mapping and you tie it to an SLA class, which is on the right side bottom, which is video SLA, now we can do measure at a queue level, at that QoS group level, the loss, latency, and jitter, which we defined for video SLA, like the loss should be 1%, and latency should be 150 milliseconds, and jitter as 30 milliseconds. So the best practice recommendation is when you turn on enhanced application aware routing, try using application probe class because it gives you more granular per queue level loss, latency, jitter measurement. This slide is for a reference, and this is going to be posted to you. Again, this is a concept that exists before. So in terms of the loss accuracy, let's look a deep dive into how we do that. So loss measurements are at a queue level using inline data packets. We use the IPsec sequence numbers. So every packet that is going on the wire is going to have a sequence number. And we are leveraging the same adaptive cost loss measurements that we use for the adaptive cost. Now we can do loss measurements at the sender and at the receiver. So this gives us a capability to detect, like differentiate between the loss that is happening on the local SD-WAN edge device, as depicted in the below on the bottom left. And we can also monitor the WAN loss on the remote receiver end. And then we can compute local loss and WAN loss that's happening on the SD-WAN network. When the receiver gets this total number of receive count, it reports back to the sender, which is the device on the left here, the loss in the BFD. So for measurement on GRE tunnels, we will add metadata header with the sequence number. If let's say we don't have the inline data packets and going through the fabric between these SD-WAN edge devices, in that case, the BFD measurement using the synthetic BFD packets, that application aware routing will still be able to use BFD measurements in that scenario. So in terms of loss measurements, when you have an app probe class attached to an SLA class, you have different SLAs on the left, and you have different egress queues on the SD-WAN edge device, and you have your WAN transport, MPLS, and public. How do we measure the loss in this case? So if you look at for SLA1, which is using DHCP enhanced expedited forwarding EF 46 and mapped to an MPLS transport. So in that case, for SLA1, we use the WAN loss of Q1. It's mapped to the Q1. And then we use the local loss of Q1. For SLA2 and SLA3, they're using the same DHCP AF3X, and they're mapped to the MPLS transport. Because they're using the same DHCP, we will account for WAN loss on both the queues. SLA2 is mapped to Q3 SLA3 is mapped to Q4. So in that case, when we want to measure the local loss and WAN loss for SLA2, we take the average of Q3 WAN loss and Q4 WAN loss because they're using the same DSCP, differentiated code services DSCP, and we use just the local loss of Q3. Likewise, for SLA3, we use the WAN loss of average of Q3 and Q4 because of same DSCP, and we use just the local loss of Q4. And for SLA4, it's local loss of Q4 and WAN loss of Q4. So this is how like granular we can get when you have approach class and you use these approach class to map an SLA to a queue on the SD-WAN edge device. In public tunnels, like when you have like public internet, there is no concept of differentiated treatment. So in that case, with enhanced application aware routing, we use for SLA1, we use WAN loss of all the queues and local loss of just Q1. So likewise, it's going to be average of all the queues for WAN loss. We have seen some deployments where approach class is not configured. In that case, when there is no mapping of an SLA to a queue and DSCP, we just follow for all SLA, we just use the WAN loss across all the queues and also the local loss across all the queues. So the loss measurement is very simple in this case because there's no per queue mapping here. For latency measurements, we use standards-based algorithms. So you have a packet that's sent on the SD-WAN network and it's received. So we measure the round trip latency time using the standard formula is shown here. Because we are using inline data packets for this measurement, we are adding this extra metadata. So we have timestamps attached to that metadata, and now we can sample this and selectively pick every packet every 100 milliseconds, and we can measure the round trip latency in this case. So in terms of latency as well, when you have approach class configured, we can provide a unique per queue latency measurements, same like loss. So in this case, in this case, like for SLA1, we use the latency of Q1, whereas for SLA and SLA2 and SLA3, because they are using the same DSCP, we use the latency of Q3 and Q4. So again, like this is going to be applicable even for latency. The per queue latency measurement, round trip latency is measured. For jitter, jitter again, like we use like since the TX transmit to receive jitter is not same as receive to transmit jitter, we use the time delay variation in latency standards based formula as shown here. So we measure the one-way jitter, unidirectional jitter. We use the inline data packets with sampling and timestamps. And the jitter, when it's got computed at the site B, it is sent to site A SD-WAN edge device using the BFD. Now, in terms of like actual absence of actual data traffic, again, we have BFD running. We will use the BFD based measurements for jitter computation. So BFD is used as a fallback when you don't have the actual data traffic running between the SD-WAN edge devices between the tunnels. So BFD is always there. So we use that, and now we are enhancing with the inline data. So all the different accurate measurements that we talked about, improvement on the measurements. When you use SLA approach class to map the queue and SLA to the transport on the WAN, you can again get more granular jitter measurement at a queue level. So for SLA1, we use the jitter of Q1. For SLA2 and 3, because they're using the same DSCP, they will have the jitter of Q3 and Q4 taken into consideration. So again, no different than what we do for loss or latency. Just the slide is there for your reference to understand. So let's talk about the dampening here. So what is SLA dampening? We have like accurate, more improved measurements using inline data packets. Now we can reduce the pole interval to as low as 10 seconds. So what this means is, like, if let's say the tunnel is out of SLA, it can be taken out from forwarding in 10 seconds. Now, let's say the tunnel is meeting the SLA again, then we will be adding that back into forwarding in 10 seconds. Now, imagine a situation where your WAN network is not stable and there are some issues that are external to your SD-WAN network. Maybe there are some issues happening on the ISP or the managed service provider. So in that case, if you look at these tunnels taking traffic and forwarding, and tunnels taking the traffic away from forwarding when not meeting SLA, you can see that the traffic can go flip-flop, right? You can see, and then this can cause like packet out of order issues. It can cause like delay variation, and the end outcome would be like your users will have a bad application experience on the network. So in order to fix this or stop this from happening, we introduce this dampening capability. When you turn on enhanced application aware routing, this is going to be added as a default, where when the tunnel, let's say, was out of SLA and it starts to meet SLA, we will not put that tunnel into forwarding for application traffic until we monitor for a configured time. And when we see that during that time there was no issue and the tunnel was always stable, like it was then only we will add that tunnel to take the application traffic and put that into forwarding. So again, there is a default time that we monitor. You can also change this time depending on your network conditions, depending on your application requirements. You can tune these dampening timers. The best practice recommendation, though, is that do not change the pole interval to be lower than 10 seconds. The default minimum is 10 seconds today. Again, I mentioned SLA dampening gets enabled by default when you have enhanced application aware routing configured. So just to double click further in a more pictorial way, what the dampening behavior. So imagine you have a tunnel between the SD-WAN tunnel between the SD-WAN edge devices, and you have your WAN circuit. And let's say at time t1, the tunnel was out of SLA, and at time t1 it starts to meet SLA. Now what we do is we start the dampening behavior where we monitor for a configured time the behavior of the WAN circuit, whether it is stable and there are no packet loss issues and network conditions are stable for that dampening duration. But let's say at time equal to 19 minutes, we saw that again the tunnel was not meeting SLA because of some instability. So then we don't add that tunnel back into forwarding. So again, we will just monitor it. And let's say at time T3, the tunnel starts to meet SLA. Again, we start the dampening timer. And now this time, let's say the tunnel is starting to meet SLA again until that duration, which is the dampening duration, which is the 20 minutes. Then we know that the circuit has been stable. The tunnel will be put into forwarding. Now it can forward the application traffic through that tunnel. So that's how the dampening automatically gets done in this enhanced application aware routing. Tanner, back to you. So do you want to post the poll question 3?
Absolutely. Once again, we appreciate y'all's participation in our poll questions today using the Slido panel or the Slido link. Poll question 3 is now live. What is the current percentage of Cisco Catalyst SD-WAN deployments that use application aware routing? And we'll kick it right back to you, Karthik.
Thank you, Tanner. So let's look at now the migration scenarios. Today, if you look at enhanced application aware routing, this is disabled by default. Now, when you want to enable this, it has to be enabled on both the SD-WAN tunnel ends, like the local SD-WAN edge and the remote SD-WAN edge. Now, again, like if let's say you have your hub sites on your SD-WAN network enabled for this feature, However, your spoke sites, like your branch sites, like remote office sites, there you have not turned on this feature. So in that case, we will fall back to using BFD based measurements. So at given time, an SD-WAN edge can support both enhanced application-aware routing metrics and application-aware routing metrics. Usually, you would start with the data center sites or your headends first, and then eventually, when you do this, you will do a rolling deployment on a site by site on the remotes. So that's the idea here is to when you have this migration happening, we will still be able to do fallback to the existing BFD based measurements. So only when both sites are upgraded to this software version and this feature is turned on, that's when we start to use the inline data packets for these measurements. So again, just in a tabular format. So if you have a site A that's running enhanced application aware routing, imagine that's a head end site, and you have site B, which is the remote. It's running application aware routing using BFD metrics. So the result would be we will use the BFD based measurements on both sides. Again, if you have site A configured for enhanced application aware routing, likewise you have the site B, then we use the inline data packets and BFD for reporting. So now let's look at the configuration for this capability. How do you the idea behind this was to simplify the configuration, how to configure this for our customers and like you. We have by default provided three options which are intent based. So one option is going to give you faster convergent times. So you have applications that are very latency sensitive, and they have to be detected whenever there's a tunnel degradation. You have to switch over the traffic faster. In that case, you can go in aggressive mode, which is going to give you 10 seconds convergence between 10 to 60 seconds. Then you have another option called moderate, which gives you in convergence times from 1 minute to 5 minutes. And again, these are like the intent based options. So let's say you have like conservative. So in that case, like you have 5 minutes to 30 minutes of convergence time. So these are the three options that are tested fully by the solution test and the system test teams, and these options are going to be what we would provide inside the SD-WAN manager. And these are again like the inner details as shown in this table. The idea is we have abstracted so that whenever you see these options, these are happening under the hood. But if you are really interested to see again the pole intervals and the multiplier and the dampening multiplier and the dampening window, you could see that in this table here. So the dampening window is going to be 20 minutes for aggressive. And it is the way we calculate that is by the dampening multiplier times the pole interval, which is 10 seconds. 120 times 10 seconds is 1200 seconds, which equates to 20 minutes. Again, obviously this is flexible enough that, like, let's say your network condition and application requirements for that network doesn't satisfy this dampening window. You can use the CLI templates or parcels, CLI add-on templates or parcels when you're using configuration groups to go change these values. So how, like, this is a screenshot from the SD-WAN manager using templates. We added this under Cisco system template feature template, and you have a new option, enhanced app aware routing. Again, these are the three modes that I talked about. By default, it will be disabled, and you can select one of these three default options. So this is from configuration templates point of. Now, if you're using configuration groups, these are again added in the part of the system profile, which is again within that system profile bucket, you have a basic parcel, and that under that basic parcel, you have an enhanced application aware routing knob, which you can use. Again, you need to turn this feature on both ends. So in terms of using CLI, you can use CLI templates or parcels, and these are the CLIs. BFD enhanced app route enable to enable the BFD enhanced app aware routing. And again, like if you're using aggressive, you have the enhanced pole interval and multiplier and the dampening CLI, which gets enabled by default. So again, so when we have these data metrics exported to SD-WAN manager, so when you go to the tunnel and you see all these stats, so prior to this, right, we were right like the SD-WAN edge device will write these records every pole interval. And if you look at the prior, the pole interval was not like 10 seconds. So that way, like now, because of this reduced pole interval, you will see that the Vantage device writes frequent writes to this records on the device, and then the SD-WAN manager will pull that and show that in the graph for you. So again, to optimize this, we are now creating this record only every 1 minute if you are using 10 seconds pole interval and the multiplier as 6. So we use every 1 minute. This will reduce the impact on SD-WAN manager. And also, let's say if within this time, if there are, SLA breach conditions happening, we don't wait for this record to, in that case, to 1 minute. Like if there is an SLA breach in 10 seconds, we report that violation. So SD-WAN manager still gives you that visibility. Now we write these records in the same file structure that we use for application aware routing in the past. So there's no change. So these are the CLI verification to confirm when this feature is turned on. Again, these are just for your reference. I will go quickly breeze through these slides so we can do the live demonstration here and have some time for the Q&A as well. So again, these are the CLIs. Most of the CLIs, if you notice, are coming from the application aware routing. Now we are adding some new enhancements like dampening index that's highlighted on the right side, and to see the feature is enabled. Again, like the remaining CLIs exist before as well. So let's look at the live demonstration now. Let me show you the topology here. So I have two sites, the brand site at the bottom and the data center site, site 600 at the top. So focus would be on brand site 700. So we have VPN 1, and we have configured an SLA class called real-time SLA and an app group class called APC real-time. And we are using DHCP expediter forwarding or 46 for MPLS transport. And we have an application routing policy that is already configured that says whenever I have an application that meets this loss and this latency and jitter, I want the traffic for this real-time application to choose MPLS as the preferred transport. Whenever there is an SLA breach condition, failover to the public internet as backup SLA preferred. So we also configure QoS because that's what allows us the SD-WAN edge device to classify traffic into different classes and queues. So we have a real-time forwarding class created, real-time class, and it's mapped to Q0. So currently the traffic is going over the MPLS path. So I will go into the details, the how part, but I want to quickly show you the demonstration first and then connect the dots. So I know this is kind of a bit different. So just keep in mind that I'll come to the inner workings after that. So let's look to the vManage now. So this we have the SD-WAN edge device, the site 700. So right now I'm just going to quickly show you in real time like what we have. So let me show you actually the traffic flow. So I'll come to that. So let's just do a quick simulation for that traffic from 10.7.100.60 to 10.6.100.60. According to our application aware routing policy, it is using MPLS as the preferred TLOC. So what I would do now is going back to the topology, I will add a 5% or 6% loss on this WAN circuit. And now we have a video flowing, a stream going through, and I will introduce the loss, and we will see how much time. Right now, these two edge devices are configured for the lowest convergence time, which is anywhere between 10 to 60 seconds. And we will introduce loss through a CLI, and then we will see how fast the convergence happened. So let me flip back to my video. So this is on the data center 10.6.160. I have a timer here, and now with the CLI, I will introduce a loss of 6% instead of 5. And then I have my SLA set for threshold for 1%. Okay. So before I add loss, I just want to you to pay attention to the video. It is playing fine. So I am adding the loss now using this CLI. So once I add the loss, I'll quickly start the timer here. And you would see that you're starting to see the stream getting distracted, like there's like a loss introduced on the network, and in 13 seconds we are seeing that like the convergence is starting to happen, and between 10 to 60 seconds you should see that the convergence happen because we are using the aggressive mode here between the SD-WAN edge devices. So and now you can see that I'll go ahead and stop. So about 32 seconds, we are seeing that the traffic convergence happened. So this is the advantage of enhanced application aware routing. So now, so let me go ahead and show you inside the SD-WAN, like SD-WAN manager. So I'll go to the slides and I'll show you. So let's go to the slide now. So what we did is, so we verified going to the SD-WAN manager where we had an application aware routing policy set up in the step one, and we ensured that it is using MPLS as TLOC. And I will show you the configuration for aggressive mode shortly, but I did show you the video traffic that flows between these sites. And then I introduced a 5%, 6% WAN loss on this circuit. And then it will see that the traffic switched over in 30 seconds to public internet TLOC. So let me go to that simulation again and run this again. Now it should use the public internet as the TLOC because of the application aware routing policy. So finally, I can remove the loss and see that the dampening is happening where the traffic will not put back into MPLS TLOC immediately because we will wait for the traffic on that tunnel to satisfy the dampening duration timer. And once we know, then we switch that to the MPLS TLOC again, the traffic back to that. Okay. So that's what we did. So if you go back to the SD-WAN manager, I will show you now all the configuration aspects um, that I did. So if I go to the device here under troubleshooting, so I'll go to the real time. So if I look for app route stats, so now you would see that like this will have an additional option like called enhanced app route. And now you would also see like on the MPLS, you will see like on the MPLS circuit, you will also see like there's going to be a loss. And so I'll talk about the class index now. So this is what the app route class we used APC real time for this SLA class. And right now you can see 0 and 1 as the SLA class index. And I'll show what the class index refers to here. So if you look at app route SLA class, so internally we use a real-time SLA class, which is mapped to an app route class. We internally use index. So this particular traffic is mapped to index 2, and this is using loss 1%, latency 100, and jitter 10 milliseconds. So what we saw that tunnel was taken out of this index because this was not meeting SLA. Okay, so that's what I showed you in that CLI. Now, where do we see these SLA classes and app pro classes? So if you go to the configuration under policies, you can see here under custom options where under lists I defined first you need to go to define the class maps, right? The forwarding classes. So if you look at these lists under the class map, you would see that I have created real-time class. For our interest, just focus on this one, but you can define like other classes for different classes of application. And real-time class is mapped to Q0. Now, if you go to the centralized policy under list, you would see the SLA class defined. So let's say if you see the APC real time, so this is what I defined. So this real time SLA class has these particular thresholds: loss 1%, latency 100, and jitter, and it's been mapped to an APRO class APC real time. And this is how you tie an SLA to an APRO class. APRO class is defined here, where you define the tuple that I talked about, where you say this particular APC real-time maps to this real-time class, which is a QoS group of Q0, and then it has a tuple of color and DSCP. So DSCP 46 traffic is going to be put on this WAN transport MPLS. Okay, so that's where I define. Now, in terms of the policy, if you look at my application aware routing policy, so this policy is applied to my branch sites, which has the site 700 and under corporate VPN, which is VPN1. And if you look at the preview for this, so you have the two classes like bulk and SLA, but like SLA class real time map to APC class real time. And if you look at the app route policy, that is what defines the SLA routing. So whenever I see real-time applications or this particular sequence of match conditions, when the SLA is met, use the action as preferred color MPLS for the real-time SLA. If like the SLA is not met, you use the backup SLA preferred color public internet. So again, these are not new concepts. These are application aware routing concepts. So I'm showing you where the policy is and how you apply this policy. So here I applied the app route policy for this under apply policy. Okay. So now, if I go back to showing you where to configure the application aware routing policy, in this, because I'm using the latest setup, I have used configuration groups. So if you edit this configuration group, so I have associated devices are my branch site 700 and 600. And under the basic feature parcel, I have enabled enhanced application aware routing. So if I edit this feature, under basic configuration, so I have turned on this feature. So this is where you would configure. By default, you can see it is disabled. Since I have already configured on both sides, right, my configuration is in place. You can also go back and see like under configuration devices. Under this you can also see the running configuration, and if you just look for the enhanced keyword, so you can see I'm using aggressive timers with the enhanced app route enabled. These are the CLIs I talked about, and for site 600 as well, I have enabled for the data center side. Remember, this feature should be enabled for both sides. So once I have this turned on, I know that enhanced app route is enabled. Now let me go back to the slides. So this is how you would configure enhanced application aware routing. So you will still get the events for the SLA violation. So all those remains as is like before. So I've shown the important one. The last demo step where I remove the loss and verify that dampening is happening. So before that, let me go to the CLI here. Again, I'll use this CLI, which will allow me to remove the loss. So I just removed the loss. Now, if you see, go back again to the SD-WAN manager and do the real time, you would see that the traffic will still remain on the public internet TLOC for the dampening duration. So once the dampening is done, then it would go ahead and switch it back to MPLS TLOC. So let me bring that back again. 10.6.100.60. So I also have a YouTube recording for this. I have the links at the end of the slide deck, so you have a detailed demonstration of this available on YouTube as well. So now you can see it still remains on the public internet, and this is how you would configure enhanced application aware routing. Okay. So with that, let me go back to the slides view. Just I want to quickly do a summary. The key takeaways for this session is enhanced application aware routing provides improved metric measurements of loss, latency, and jitter by leveraging inline data packets, the packets going through the router, and BFD for reporting and fallback. It provides faster tunnel degradation detection time and switchover time in the order of seconds, which we have seen in the demonstration, in the live demonstration, where we can now, because of the improved metric measurements, we can now go as low as 10 seconds detection time whenever there are network degradation, soft degradation issues occurring on the WAN. Last but not the least, it provides a smooth application experience for users using the applications by providing dampening so as to stop moving the traffic back and forth between SD-WAN tunnels when there are network instabilities issues happening. So with that, here are the references which you can use to look at more information on. You can learn how to enable this, and like all the links and the videos that I talked about and the prior features that are needed to understand like the APRO class or the per class application aware routing. So all these links are going to come handy for you. So with that, that concludes my session. So I hope this was helpful. And if there are any questions that are not answered on the Q&A panel, where I can now take some questions. Tanner, do you want to take it forward?
Sure. Just as a quick reminder for our participants too, if you do have a question for Karthik, please use the Q&A panel here on WebEx, and we will provide you with a response. And also those references that Karthik just shared, we will add those to our post-webinar discussion thread on the Cisco Learning Network. I'll share the link where you can find that here momentarily as well. A couple questions here for you, Karthik. Let's grab this one. Is this supported on all SD-WAN edge devices?
Yes, this is supported on all iOS XE SD-WAN edge devices. All platforms are supported for this. Yes.
Great. Let's move to another question here. Is there any impact to throughput?
Yes, that's a very good question. If you remember my session earlier, where for latency and jitter, we are adding some extra metadata, about 12 bytes of header. Every packet once every 100 millisecond, right? It's not like lot of impact to the throughput, I would say. The performance testing is happening as we speak for all the platforms. However, it will be impacting the throughput performance because of that additional header.
Perfect. Just had another question here come in. Do we have a roadmap yet for EAAR, or when are you planning to introduce and or enhance in the future?
Actually, the enhanced application aware routing capability exists today as of 20.12.1 release that we shipped, and 17.12.1a that we shipped. And there are going to be improvements as to like bug fixes and all that for this in the subsequent releases. However, this is available today.
Perfect. That is great to know. Here, I think for at the moment that does cover all of our questions. Do you have anything, Karthik, that you want to touch on here before we do wrap up?
No, I think I just want to provide like provide one insight is like test it out, and I just want to share that we have a tier one MSP provider in Northern America who has like extensively validated this and running in their in their networks, and we have got like positive feedback on this, especially like they really like the improvement on the loss. Now we're doing like three-digit floating, three-digit loss measurements. which was not possible before enhanced application aware routing. So we received a very positive feedback. Go run it in your networks, test it out, do a proof of concept, and do classification of your applications. Like I mentioned, just it's going to be readily available. So just use it in your network.
Beautiful, thanks. One more question actually just came through, if you don't mind, that we answer it here real quick before we do wrap up. Is there a plan to add SNR measurement as one of the PM metrics specific to the wireless access transport?
Yeah, I think that's a good question. So right now, this is not in the roadmap. Again, we are focusing typically like the application traffic that uses like either north south towards the wide area network to into the clouds. When it comes to the wireless, if there is such traffic flows, that's something we'll have to take a deeper look. But right now, to answer your question, there is no metric for that in this current capability. But that's a very good feedback. I will take that feedback, and we'll try to see where it fits, and happy to discuss offline. Basil, I know you posted that question, but I'll be following up with you to gather additional information. And Satish is our product manager, who is my partner here. He also is looking. And Satish, do you have any feedback to that, or do you want to add something?
Thanks, Karthik. Definitely, we would like to get more details on this ask and then the use case to kind of prioritize in upcoming roadmaps. Yeah, that's one. And second is just to add to what Karthik had shared earlier, this capability is already available in 1712. It got released in August 2023, right? We'll be happy to kind of learn the more use case and any enhancements that you will be looking. Please ping us and we can have a discussion and prioritize in upcoming cases.
Perfect. And thank you to everybody who did provide questions today and that chipped in on answering our poll questions. I have provided a link in the chat screen to the post-webinar discussion thread on the Cisco Learning Network, where you can find some of the resources that Karthik shared today. And we can also continue our discussion about today's session. And that post will also include the playback on YouTube, so you can watch this session at any time. Also in the chat screen, I have provided a link to where today's session will be uploaded to the learning plan. Usually takes about 5 business days for that to get uploaded as well. Want to thank Karthik and all of our panelists and the whole team for bringing your knowledge to the Cisco community today. If you do have a question, we will keep that Q&A window open just for a couple more moments. For even more tutorials, demonstrations, and future webinars, please visit the Cisco Learning Network. Your feedback is important to us, and at this time, you'll be directed to a post-webinar survey. Please take the time to participate in that. It helps us plan out some of our future sessions. Once again, we thank everybody for joining us today, and we will see you next time on the Cisco Learning Network.